Hello everyone and welcome to Mathematics. This video will focus on chapter 4, Permutations and Combinations, and let's aim ourselves to learn 3 things from this video. Alright, so I'll let you have a few seconds to go through these questions first, and for part B and part C, y'all can try out to determine whether it is a permutation question or a combination question. Alright, so for part A, we need to solve this equation, or in other words, we need to find the value of n. So there's a method I would like to introduce to y'all, which is the 3E method to help us find the value of n. So the first E here represents employ. Another word for employ is apply. So we can use the formulas that we learned in this chapter, apply into here to further simplify and find the value of n. So according to the SPM formula sheet for this chapter, we have two formulas, formula 21 and 22, which is nPr and nCr respectively. Alright, so going back to our equation, you can see that there is one p here, so we need to use the formula 21. So for our case, 2n here is actually the formulas n, and n here is actually the formulas r. Okay, so if we change n to 2n and r to n, this would be our result. And for the other things, it doesn't change. Okay, so now we can further simplify this, so it will become n, and here I can move it to the top, so it will be at the denominator of this fraction. Okay, so it will be something like this. So this brings us to the second E, which is expand. Alright, so what is expand? So if you refer to this formula, this is the n factorial, and we are trying to expand its value. Okay, so the first value would be the original value, which is n, and going to the next number, we need to minus the original number with 1. So here it will be n minus 1. And going to the next number is the same thing as well. We do minus 1 again, and so on. Okay, so let's give a numerical example. Let's say 8 factorial. So I'll start with 8, and then we go to the next number, we will minus 1. And minus 1 again, and minus 1 again, and so on. So let's say I stop at 5. Okay, but the minimum value that you can stop is actually 1. Okay? It is not 0 and it is not negative 1. 1 is the minimum value. Right, so why are we using this expand method? Okay, because if you compare the factorials on the left side of the equation, you can see two of them has 2n. So maybe we can expand this factorial to become this. Okay, so let's say here 2n, and if I want to get the next number, it will be 2n minus 1, and another number 2n minus 2. Now you can see these two are actually the same. Okay, so here 2n minus 2, we stop at here. So this brings us to the third E, which is to eliminate the things which are similar. So here 2n minus 2 factorial, we can cross off, and left side and right side we have n factorial. Okay, so we can cross off as well. So this would be the simplified equation, which is 2n multiplied by 2n minus 1 equals to 10n. Okay, and we further simplify this. So by further simplifying, you can factorize here with 4n. So here will be 4n bracket n minus 3. So you split it into 2, there will be 2 answers. But we need to reject one of it, which is this n equals to 0, because if you imagine nPr, if the n is 0, means that we are arranging 0 stuff, which actually doesn't make sense, correct? So here you will use n equals to 3. Moving on to part B, we have one Shahita who would like to arrange these 8 beads to form a bracelet. So the question asks, how many bracelets can she form if there are 3 beads which have the same color? Okay, so here the key word is actually arranges, means this question involves arrangement, which also means this is a permutation question. So to find the different ways that she can form the bracelet, we need to consider its conditions first. The first one is actually, since we are making a bracelet, the beads arrangement, we need to make it into a circular arrangement. Okay, so this is our first condition. The second condition is bracelet is a thing that can be worn, correct? So for these wearable items, we need to do some calculation to make sure we get the correct answer. Okay, and lastly, we have beads have the same color. So here also involves another condition, which is we have identical items. Okay, so let's go to the first condition first. So now we are taking all the beads and arrange them, correct? So according to the table of formulas here, now our condition is selection is all, arrangement is circular. So we need to use this formula, n factorial divided by n, or you can write n minus 1 factorial. These two things are the same. Okay, so the value of n here is the number of beads, so here would be 8 minus 1 factorial. Okay, so this is the first condition. Now the second condition is wearable. So for all wearable items, let's say bracelet or necklace, we need to divide our answer with 2. Okay, so why is it so? This one I have explained this in another video, so I explain this in quite detail, so you can refer to the link that you will be seeing now. Okay, so for the third condition, it will be identical. So for identical objects, we need to do this. For every item that has duplicates, we need to divide a factorial, and the number of that factorial would be the number of duplicates. So going back to our question, every item here you can think it as every color which has duplicates. So going back to our question, we only have one color has duplicates, correct? So here we only need to divide 1 factorial, and the number of that factorial would be the beads, which is 3 of them. So here we just need to divide 3 factorial. So here you get the answer is 420. So you'll be maybe wondering, if let's say we have another condition, let's say another 2 beads have the same color but different from this color. Okay, let's say this color is blue. Let's say the new one here is red. So how do we find the number of arrangements? Okay, so here the same thing as well actually. The extra thing is because here we have 2 colors have duplicates, so we need to divide 2 factorials. So the first factorial's number would be this 3, and the second factorial's number would be the 2 beads lah. So here would be 2. So here we divide 2 factorials. Alright, so going to part C, we have Harris which own these items, and the question asks how many ways can Harris choose if for each item he choose 2 of them. Okay, so here our keyword would be choose. So here we are choosing things from a set of items. So here it will be C, a combination question. Okay, so I wouldn't need to know whether the shirt I have taken from this is the first one, the second one, and so on. I just need to select that shirt, and that's it. Okay, so here the shirts, from 5 shirts we choose 2 of them, so it would be 5C2. 7 pants we choose 2 of them. 4 pair of shoes we choose 2 of them. So to find the number of all possibilities, we need to multiply these 3 numbers. So the total ways would be 1260. And with that, we have completed today's question. Alright, so here's the take home points for this video. So the first thing is for these permutation and combination equations, we can use this 3E's method. So it's employ, expand, and eliminate. So the first thing, employ, we need to use the formulas we have learned in this chapter and we apply it to our equation to further simplify. And the second E is expand. So just now the example I gave y'all is n factorial, and we can expand it, so it will be something like this: n minus 1, n minus 2, n minus 3, and then we stop at n minus 3, we need to put a factorial. Right, and the third E will be eliminate. So for the things which are similar, just need to cross it off. The second thing we need to know is for these variable items, let's say bracelet or necklace, we need to divide our answer by 2. And the third thing is for these identical items. So if we have our answer, which is all possibilities, and we need to divide for every type which has duplicates, we need to divide a factorial for every type, and we need to use the number of duplicates for that type. Okay, so let's say we have 2 types of items which has duplicates. Let's say these blue cards and green cards, we need to divide 2 factorials, and the number of factorials will be according to the number of duplicates that the card has. Okay, so here's the answer key for this question, and hopefully you've learned something new from this video. So if you feel this video is beneficial to you, please give a like, subscribe, and share. So thank you so much for watching. I'll see y'all in the next one.